Alrighty. Logs. So logs are kind of related to exponential functions, which is what we were doing last unit, which you just wrote your test on yesterday, right? And I'm almost done marking those. Those will be in by the end of the day. So an exponential function, like what we were dealing with all of chapter 7, looked like this. Okay, it had an exponent in it. Very simple. Exponential functions have inverse functions, okay, where the x and the y change or swap. That's the definition of an inverse function. So if we inverse the y and x in this original equation here, it becomes x equals c to the y. Okay, very simple. We're just swapping them. But this function is also known as a log function. And this can be written as this as well, y equals log c to the x. So every question this unit is going to have a log in it, okay? And there are two forms we're going to be working with. Now, I apologize, on your sheet, I wrote exponential function. That word probably wasn't the best word. I changed it to form, okay? So this is exponential form. I'm just typing too fast. Exponential form. So I'm gonna just kind of walk you through how we go between exponential form and logarithmic form, because we're gonna be doing that a lot this unit, and it just has to be like in your blood. You just gotta be able to do this super, super quickly, okay? So for example, this first one here, I have 5 to the power of 3 equals 125. We all agree that is true. 5 times 5 times 5. That is an exponential form because it has an exponent, okay? We are going to rewrite this as log form. So this is how we do that. Whatever the big fat base is in exponential form, so the big fat base is 5, that becomes the little guy in the log. And that we call that the base of the log now. So the big fat 5 was just called the base of the power. Now over here, it's called the base of the log. And it becomes like a subscript, really little, okay? Then the next change we have is the answer, which is 125, gets glued beside the little 5, okay? And then the exponent becomes the answer. So that sounds very complicated, but it's really not. When you see this, all it's asking you to do is you ignore the word log, to skip over that. What it's asking you to do is figure out 5 to the power of what gives me this number, and that's the answer. So our answer that we're searching for is
Sorry for the interruption. This is one last call for all choral students to go to the buses. That choral keys to the buses right now, please.
So the answer to a log function is 5 to the power of what gives me 125. So you're searching for what exponent should go on the 5 so that it becomes 125. That's why the answer is 3. 5 to the 3 gives me 125. That's the answer. Okay, so same thing here. Okay, I have 32 equals 2 to the 5. That's exponential form. So just like we did in the previous one, the base of the power, the 2, now becomes the base of the log, and it becomes a little guy, okay? The answer of 32 now becomes my big fat base, and the answer of this guy is going to match up with the exponent there. So in other words, once I erase all of that, if you go over here and you are given this question, all I'm asking you, like this part would not be given to you yet, okay? All I'm asking you is 2 to the power of what equals 32. So what exponent would you have to put right there so that 2 to the power of that equals 32? And that's how you get the answer of 5. So the answer is the exponent you would need. Okay, that's all that logs are. Okay, another thing. Sometimes you are going to be given a log that looks like this, and there is no little guy. See how there's no little guy there? All logs should have a little guy. If there's no little guy, that's called the common logarithm, and it's automatically a 10. Okay, so that's why I put the 10 there. So if you see a space where there should be a little guy, that's a default of 10. So you can always add that in. So that's why I wrote that little note here. Base 10 is called the common logarithm. So because it's the common logarithm, it's not necessary to write that 10. It's just kind of a given, just like a denominator of 1 is always given. Same type of idea. Okay? Another very important thing. You cannot take the log of a 0 or a negative number, and the base must also be a positive number. So when you have your log, oh, where's my pen? Log, and then you have your random little exponent down here, and then you've got your base and you've got your answer, something like that. These two guys, those two must be positive numbers and non-zero. Okay, those two. The answer could maybe be negative or 0, but these two guys right here, the little guy and what it's attached to, those have to be positive and non-zero. So we're always going to check for that. So let's just get right into it. All I'm asking you here is to evaluate. So like I was just talking about, if you see log 2 to the 8, all I'm asking you is 2 to the power of what gives me 8. That's what logs are asking you to do. Find the missing exponent. What do I have to put on a 2 to make it an 8? A 3. The answer to this is just 3. Okay? Next one. And you don't have to write this part out. I was just kind of showing you what it's actually asking. You can just go boom, straight to the 3. Okay? Log of 100. Now you'll notice we are missing the little guy. We just talked about that. If you're missing the little guy, it's actually a common logarithm. There's a 10 there. So in this case, I'm asking 10 to the power of what gives me 100. That's what you always say to yourself. Well, we know 10 to the power of 2 gives me 100. Done. So logs kind of look scary off the hop, but they're really, really not. They're asking you the same thing every time. Okay, here I'm trying to make it a little bit more complicated. Log of 27 equals 81. So I'm asking you 27 to the power of what gives me 81? What's the problem? 27 can't give you 81, right? If we square it, we're way, 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 way up. So we're going to kind of go back to what we were doing in lesson 3 of chapter 7, where we have the exponents. Okay? So what you're going to do, what you can do is you can create an equation, just like we saw in lesson 3 of chapter 7, and which was on your test yesterday. So plug in that question mark with an X. We're looking for X. But like lesson 3 of chapter 7, you cannot evaluate that or find X until your bases are the same. So Kaden, I saw you putting 3 fingers up because you know we're going to change both of those to be base 3. So I'm going to change 27 to be 3 to the power of 3, but he is now multiplied to that X that was already there. And then 81, rewrite that as a power of 3. Okay. So then now that your bases are the same, you can drop them. 3x equals 4, divide each side by 3, and x equals 4/3. Okay? And if you want to verify, you can, by all means, but you don't have to in this unit. But the way you would verify, you just figured out that x is 4/3. So you would just plug that in. And then you would figure that out however you want to. You could maybe do like that. Okay, does that equal 81? Well, cube root of 27 is 3 to the 4. Yes, 3 to the 4 equals 81. So just plug your x back in and make sure it works. Okay, but that's optional this unit. All right, so that's how we evaluate logs. Not so bad. We're going to get a little bit more complicated here because you'll notice in every single one of these questions, x is in a different spot. Okay, sometimes I want you to find x, which is the little guy or the base of the log. Sometimes I want you to find the big fat X. Okay, you got to know how to deal with those. We also have to make sure that all of our answers are positive, because I said above that these guys, right, these guys in these positions can't be negative or 0. So we're going to also make sure that our answers fit the script there. Okay, so the first one, log x 64 equals 2. So this time here, our x is in a different spot. Okay, so things change a little bit. So I'm essentially asking you, x squared equals 64, because I gave you the answer. And remember I said the answer is what the exponent should be, okay? So whatever the answer was, which was this guy, this is my answer, he's always the exponent on the base of the log. So I put that 2 on whatever the base of the log is, and that has to give me 64. So we're just kind of working in a different direction now. I gave you the answer, so I gave you the exponent, and we know it equals 64. Now, I know you know that the answer is 8, because we're smart people. 8 squared is 64. You do just have to show work here, and there's 2 options to show your work. You have to solve for x. We learned how to solve for x with exponents of 2 back in pre-calc 20 and also foundations 20. There's 2 methods you could use here. Square root method is the first guy. Take the square root of each side. You have x equaling plus or minus 8. Yes? Okay. The other option is you could have brought that 64 over, made that 0. You could have factored x minus 8, x plus 8, because it's a difference of squares, and you would have gotten also that your answers are positive 8 and negative 8. I don't care. What's my answer going to be? What's my final answer? 8, negative 8, both, none of them, no, just 8. You cannot use the answer of negative 8. I already told you that this guy right here cannot be negative. So we're not going in. So that's why I'm going to cross off the negative 8. We're not going to include it. So our final answer for this guy is just 8. So 8 squared equals 64. We know that's right. That was a pretty basic one. Okay, let's practice that again. This time I gave you something different. I want you to find x, which is a big fat X. Okay, that 3 is the little guy, not the x. The 3 is the little guy. But now you have brackets. What I always want you to do is just rewrite this in exponential form. Get the log out of there and rewrite this as an equation. Remember how I told you? The answer is always the exponent. And so we're going to write down a little 2. We know we've got a little 2. That little 2 always goes on the base of the log, which is 3. So now we've changed that power to be 3 to the power of 2. And then this guy here is what we want to solve for. We want that to be equal to x plus 4. Okay, this one's actually not that bad. Don't freak out. Just solve that. 3 squared is 9. Boom, minus 4 to both sides. X equals 5. Okay, now this you can do a mental check of. I'm just going to write it down for the people who aren't here. We have to also check that this guy is positive. Remember I said both of them have to be positive, this little guy and what's in the bracket. So we have to make sure once we plug our x into that bracket, it gives us a positive number. And of course, you could have done that in your head. We know it's 9, okay? But just remember to do that. Sometimes once you plug your x in, maybe it'll give you a negative and you can't have that. All right, 2 more left. Moving on. Okay, this thing here. Now the x is that big fat guy there. There's no brackets or anything. Remember, the answer that it gives you, answer becomes the exponent. So I'm going to have a little tiny 2 over 3. And that little tiny 2 over 3 always goes on top of what the base of your log is. And then on the other side is what you want it to equal to. Okay, so let's solve for x here. What I would do here is I would convert that exponent, that fractional exponent, to a radical. So I know my denominator is 3, so that's my new index. right? But then I have to remember that I also have a numerator of 2 in that fraction, so that goes on the outside. So I'm just rewriting that. I'm going to do that because I know I can take the cube root of 125. That's easy. That's just 5. So there you go. My x is 25. Okay, just do your quick little check. Are all of my values positive? Yes. They're 125 and 25. I have no positives, no negatives, no zeros. I'm happy. Okay, last one. Okay, so I hope you've gotten the hang of it now. This guy, the answer is going to become the exponent. And it always is the exponent on whatever the base of the log is, which is x, and that's going to be equal to the big fat number. We want it to equal 27. Okay, so you have to solve this. This might be a little bit of a trickier one for you. There's multiple ways to solve this guy. We want to get x all by itself. Any takers on how you could get x all alone here? How do we get rid of the 3/2? Any ideas? Ethan? Yes, that's absolutely right. So what Ethan wants to do is to essentially get rid of the 3/2. Okay. So the 2, or sorry, I'll start with the 3. The 3 means you're cubing it. That's what that means. So to undo that, you would cube root it, right? Then the 2 means you're square rooting it. Okay, so we're going to square it. In other words, this is what you're allowed to do to make your life easy. If you want to cancel out an exponent of 3/2, raise it to the power of 2/3. And I'll show you why that works. You're going to raise it to the reciprocal fraction. So instead of 3/2, it's 2/3. The reason being, because now we know exponent laws say we have to multiply those together. So if you multiply that, you get 6/6. And 6/6 is just 1. So we've gotten x alone. But what we do to one side, we have to do to the other side, right? So over here, because I have 27 to the power of 2/3, the 3 means we cube root it, and the 2 means we square our answer. So the cube root of 27 is 3, but then you square it, and that's how you get an answer of 9. Okay, so you just go back and check, are all my values positive? Yes, they are. We're happy. All done. Okay, so that's an introduction to logs. Just swap stuff around. This is your assignment right there. This won't be due until Wednesday of next week. So you literally have a whole week to do it. But you could also just get to work right now because you have 40 minutes and hammer it out and get it off your plate for the long weekend. That would be what I would do. And let's stop recording.